We'll continue with our lesson on simplifying radicals, and we were doing this by breaking to primes. So we're going to break this one down. For 40, I see 4 times 10. There are other ways. You will always get the same answer at the end. So 4 will keep breaking to 2's, and 10 will be 2 times 5. So I have all primes there. I'm going to put it back under the radical. So I have 3 2's, 1 5, 2 A's, and 5 C's. And now we will make groups of 2 because it is a square root. That's why you make groups of 2 items. So 1 2 will go out for this group. This 2 will stay. There's not another 2 to go with it. The 5 will have to stay. For the A's, we do have enough for a square there. So we can take 1 out for that group. For the C's, 2 C's can go out. So that will be a C squared on the outside. We'll just put 2 C's for right now. And we'll put it all back together. So on the outside, we have 2AC squared. Underneath, we have a 2 and a 5. We'll multiply those back together to give a 10. We don't have any more A's. We have 1C. So 2AC squared times the square root of 10C. For our next problem, 4 times the square root of 18x squared. So we just leave the 4 for right now because it's outside the radical. We're only trying to see can we simplify underneath. So for 18, we could do 2 times 9. And 2 won't break. 9 will do 3 times 3. And we have 2 x's. So I'm going to carry my 4 over so it'll all be together. I have a 2, 2 3's, and 2 x's. Right? It is a square root, so we're going to look for groups of 2 factors that would make a square. We can't do it with the 2. For the 3's, we can take a 3 out. It will multiply by the 4 on the outside. For the x's, we can take an x out. So 4 times 3 will give us 12x on the outside. And what we have left underneath is just a 2. So whatever you take outside will multiply by what is already there. Next, we have a cube root to simplify. You start the same way. We want to break 135 down and make sure there are no cubes left inside. Right? The easiest way I think to start with this one is because it ends in 5, there's a 5 in there. So we will use a 5 and just divide 135 by 5. Goes 27 times. My 5 is prime. 27 is not prime, but that's an easier number. It is 3 times 9. 3 is good, and 9 is 2 3's. So right here is our cube. We'll go ahead and write it. Anytime you get 3 copies, that would be your cube. Right, so I have 3 3's, and I have a 5. Now, when you're doing a cube root, you have to have 3 to make a group. Whatever the index is, that's how many have to be in your group. So 1 3 can go outside for that whole group. The 5 will have to stay. It does not have anything else to go with it to make a cube. You have to make sure that you keep your index. Otherwise, you will think it is a square root. Right, so 3 times the cube root of 5. Next, we have the cube root of 192x to the 5th. So 192 is kind of a hard number. It does end in a 2, an even digit. So we know there is a 2 that will divide in there. So we will divide by 2. And when you do that, the 2 goes in 96 times. All right, still not an easy number. But 96 is even, so we know there's a 2 in there. So we can break with a 2 again. And 2 goes 48 times. Then it's getting to something we might know. 48, we can do 6 times 8. I'm just carrying these down. 6 is 2 times 3. And 8 is 2 times 4. The 4 will keep breaking. So these I'll bring down one more time just to keep them all together. And 4 will be 2 times 2. Right, so now we'll put it back together. We have a cube root. We have 1, 2, 3, 4, 5, 6 2's. And a 3. And we have 5 x's. Right, so our index is 3. That means 3 copies make a cube. 1 will go outside for there. There's us a cube. Big cube root of 8, which is a plain old 2. Going to the outside. Here is another group that makes a cube. So a 2 will go out of that group. We'll multiply by the one that's outside. The 3 will stay. For the x's, for 3 of them, they can make a group. So 1 x going outside. So we'll multiply these together outside. 2 times 2 is 4. And we have an x. Put your radical symbol back. Make sure that you keep your index. Right? Underneath we have left a 3 and 2 x's. So that will be x squared. Next we have one with just variables. We'll go ahead and write this one out, but I'm going to also lead you into the next rule. Right, so we have a cube root. We have 6 x's. We have 5 y's. We're going to make groups of 3. So there is one group of x's. So one goes out and another one goes out. For the y's, 1 will go out. The other 2, that's not enough. It's not 3. So we have x squared y on the cube root of 2 y's left. That will be y squared. Right, this is our answer. And that 3 should be a little bit better on that hook. That is for the cube root. Right. Remember earlier I said that you could divide with your variables, your index, into the exponent. And then we only looked at ones that worked out evenly. But let's see what happens here. If we divide 3 into 6, that does go evenly. It goes 2 times. So that gives us an x squared on the outside. That's exactly what happened when we also made the picture. Let's see what happens with the y. Right, if we divide there, it doesn't go evenly. 3 goes into 5 one time, but you have 2 left over. And that is actually exactly what happened with the picture. We had one group, so 1 goes outside, and inside are the 2 that are left over. So you can go ahead and just divide by the exponent. If it goes evenly, then you don't have any left inside. That's how many it goes outside. If there is a remainder like on the y's, the remainder is how many goes inside underneath the radical. Our next problem has a fraction under the radical. There's nothing we could simplify underneath, so we'll go ahead and make it into 2 radicals. And then we'll simplify what we can. The denominator is the easy part here because square root of 100, this is a perfect square, it is 10. You can do your primes, but you will see it's going to be a 10. For your numerator, right, you can make the picture, or you can try that division I was mentioning. All right, our index on this one is 2. I'm going to just put a little 2 there. Anytime you don't see a number there, it's automatically a 2. Right? 2 goes into 2 one time. So the x is going outside. The square root of x squared would always be just x. Right? For the y, if we divide, 2 will go into 3 one time with 1 left over. So we'll take a y and we will put the radical back with 1 y left over. This picture would be x times x, y, y, y. Groups of 2. X goes out. 1x for that group. For the y's, 1y goes out for this group. This is what is left underneath. For our next few problems, we want to make sure to use that division rule, the index into the exponent, because this is too many to write out. So 3 will go into 30 10 times. So this one goes evenly. That is a perfect cube underneath. So we can take 10 out. Right. 3 goes into 15 5 times. So this one is also a perfect cube. Can take 5 y's out for that. And so there is no radical left because they went evenly. Right, another one with variables. This one is a fourth root. We're going to divide on this one. So 4 will go into 9. It will go 2 times. 2 times 4 is 8. So we have 1 left over. All right, so it goes 2 times. So that's how many x's go outside. And we'll have 1 left to go underneath. I'll make just a little x here so I remember. For the y's, 4 will go into 7. It will go 1 time. And then we will have 3 left over. So 1 going outside, 3 left going on the inside. Now we'll put it back together. It is a fourth root. We have an x left, and we have 3 y's. All right, this one will give us a lot of practice with that division of the index. So for our x's, we're doing cube root of x cubed. It's going to be just 1x going to the outside. You can do your division. 3 goes into 3 1 time. No remainder. So just 1x to the outside. For the y, 3 goes into 9 3 times. 3 times 3 is 9. So we can take out 3 y's. For the z, 3 goes into 7 2 times. So a z squared. And I should leave some space and put my remainders. All right, I did not have any remainder with the first one. 3 goes into 3 1 time. Nothing left over. 3 goes into 9 3 times. Nothing left over. 3 goes into 7 2 times. That's what went outside. 2 times 3 is 6. So we have a z left over. Right? Then we have 3 into 5. It's only going to go 1 time. And there will be 2 left over to go back underneath. So this is our full answer.